Good afternoon, everyone. Today we're going to work on IXL assignment EQZ, converse of the Pythagorean theorem. Is it a right triangle? All right, if we break down the name of this assignment, just to make sure we're on the same page with our vocab, the word converse is kind of another name for opposite or backwards. We're going to be proving the Pythagorean theorem in reverse. And what we're proving in reverse is whether or not a given triangle is in fact a right triangle, because the Pythagorean theorem only works with right triangles. It doesn't work with any other kind, specifically those that are right triangle. So what makes a right triangle? Well, a right triangle is made up when we have a right angle inside. So one of our angle measurements is 90 degrees. That's a right angle. That creates a right triangle. And whenever we have a right triangle, we're able to use the Pythagorean theorem. And here's our equation for the Pythagorean theorem. It is a squared plus b squared equals c squared, where a and b are considered the legs of your triangle, and c is your hypotenuse. So if we come and look at our diagram here, the legs, those are the two sides that come together to form your right angle. And it doesn't really matter which one's labeled A and which one's labeled B, but it does matter that those are called the legs. They're the two sides that come together to make that right angle. Then your hypotenuse, that is the side that is across from your right angle. So it's that diagonal, it's across from our right angle. That is what we call our hypotenuse. The other important thing to note about the hypotenuse is it is always the longest side of a right triangle. So those are the two key things to remember is your hypotenuse is across from the right angle if you're looking at a picture. And if you don't have a picture, your hypotenuse will always be the longest side. All right, let's switch on over to IXL so we can see how we can use the Pythagorean theorem to prove whether or not a triangle really is a right triangle or whether it's some other type of triangle. All right, here we are on IXL, assignment EQZ, converse of the Pythagorean theorem. Please remember that IXL itself has some awesome resources. You can click this to learn with an example. So when you open it up, it's a PDF. It shows you step-by-step how to solve the problem, or you can watch the video that IXL has made. These are great resources, so please check these out if you would like a little bit more practice after this video. All right, let's check out our first question here. So a triangle has sides with lengths of 5 kilometers, 12 kilometers, and 13 kilometers. Is it a right triangle? So we know that the Pythagorean theorem, a squared plus b squared equals c squared, only works with right triangles. It doesn't work with any other kind. So we can use the Pythagorean theorem to prove whether or not this is a right triangle, because if these side lengths work in the Pythagorean theorem, then that means they in fact would form a right triangle. So as we were talking about a moment ago, when you don't have a picture or a diagram, the hypotenuse is always going to be your longest side. So I have the side lengths of 5, 12, and 13. 13 is obviously the largest, so that means that is going to be our C. That is our hypotenuse. And then the other two sides are our legs. It doesn't matter which one we call A and B. It just matters that we know those are the legs and not the hypotenuse. I'm just going to go ahead and list the first one as A and our second one as B. Now that we've done that, we can substitute these values into our Pythagorean theorem, and that will help us determine whether or not it works and whether or not it is a right triangle. So remember, substitute, it's like substitute teacher. You have somebody that's coming in and replacing your regular teacher for the day. When we substitute values, we're taking our numbers and replacing our variables with that. So our 5 kilometers is side A, or leg A. So instead of A squared, we're going to have 5 squared. Then our 12 kilometers is side, aka leg B. So we're, instead of having B squared, we will have 12 squared. And then we're trying to determine if that really is equal to C squared. Our hypotenuse is that longest side. Our hypotenuse is 13. So it would be 13 squared. All right, now let's solve this equation and see whether or not it actually works. So order of operations tells us we want to deal with exponents before addition, because those are the two operations I'm seeing. I'm seeing exponents and a plus sign. So 5 squared would be 25. Remember, 5 squared means 5 times itself twice. So 5 times 5 is 25. And then 12 squared, remember that's 12 times 12 is 144. And that is equal to 13 squared. Now, I have asked you to work on memorizing your perfect squares 1 through 12, just because, like your multiplication facts, those are the most common ones. And if you memorize them, you can quickly perform that operation. But anything above 12, I'm not asking you to memorize. So if you would like to use a calculator to figure out 13 squared, you're more than welcome to. So 13 squared would be 13 times itself twice. So 13 times 13, and that is 169. Next up would be addition. So we have 25 plus 144. And when we add those, we get the answer 169. And is that what we were expecting to get? Yeah, we were wanting it to equal 169, or another way of looking at this is we can just bring that down and we see that we have a true statement. 169 really does equal 169. So because these numbers worked and I got the answer I was supposed to, I got a true statement, that means our answer is yes, it is a right triangle, because the Pythagorean theorem, which we used here, only works with right triangles. So our answer would in fact be yes. All right, let's try another one here. A triangle has sides with lengths 3 millimeters, 4 millimeters, and 5 millimeters. Is it a right triangle? So once again, our first step is going to be to identify our hypotenuse. Our hypotenuse is always the longest side. 5 is the biggest number. That's our C. And that means the other two numbers here are our legs. It doesn't matter which is which. I'm just going to make 3A and 4B. Now we can put this into our Pythagorean theorem and see if it works. So our Pythagorean theorem, remember, is a squared plus b squared equals c squared. And this only works for right triangles. So by us putting our numbers in, if it works, it's a right triangle. If it doesn't, it's not. So a squared, our side length A is 3. So we're going to have 3 squared plus b squared. Our side length B is 4. And that is equal to c squared, which is our hypotenuse of 5. All right, let's simplify to see if this works. 3 squared would be 9, plus 4 squared would be 16, equals 5 squared, which is 25. What do we get when we take 9 plus 16? We get 25. So once again, we have something that works. We got the answer we expected. We have a true statement here, meaning these numbers check out. This would in fact be a right triangle. All right, let's try another one here. So when you get higher up into the SMART score, your numbers are going to get larger, but that's okay. Like we talked about, once you get past the number 12, you do have permission to use a calculator to do those squares. A triangle has sides with lengths of 28 kilometers, 45 kilometers, and 56 kilometers. Is it a right triangle? All right, our hypotenuse is always the longest side. Our longest side is 56. That's going to be our c squared. Go ahead and put that in. And then our other two sides are our legs. We'll make 28 kilometers A and 45 B. So A squared, 28 squared, plus B squared, 45 squared. Let's see if this works. Let's see if this is a true statement. So 28 squared is 28 times 28. That is 784. Plus 45 squared, 45 times 45 is 2025. And that is equal to 56 squared. Let's see if I have enough room here. I think I do. 3,136. Large numbers, but that's okay. Just be careful when you write them down not to miss anything. All right, let's see what happens when we add. So 784 plus 2,025 gives us the answer of 2,809. Is that what we were supposed to get? No, we were supposed to get 3,136. These are not equal. This is not a true statement. So what that tells us is these three sides would not make a right triangle. They could make a different type of triangle. It's possible, but we know for a fact that it would not make a right triangle, because if it did, the Pythagorean theorem would have worked. But since it didn't work, that means these three sides would not make a right triangle. Our answer would in fact be no. All right, let's do one more problem here together. A triangle has side lengths with lengths of 76 feet, 95 feet, and 57 feet. Is it a right triangle? All right, the only difference I see here when I'm up into the higher SMART scores is it's in a different order. It's not always going from least to greatest, so you need to read it carefully to make sure you pick the proper hypotenuse. And remember, your hypotenuse is the longest side, all right? So 76, 95, and 57. This right here is the longest side. That would be our c squared. And then our other two would be our a and our b. It doesn't matter which one's which. I'll make the first one a and the second one b. So let's substitute those into our formula. A squared, 76 squared, plus b squared, 57 squared, equals c squared, 95 squared. Let's simplify and see if this makes a true statement. 76 squared is 5,776, plus 57 squared is 3,249. And in order for this to be a right triangle, that would need to equal 95 squared, which is 9,025. Ooh, some big numbers. So when we add these up, 5,776 plus 3,249 gives us 9,025, which is what we were looking for. That means this does work. These three sides would in fact make a right triangle. All right, for the super quick recap, if you plug these numbers into the Pythagorean theorem and it works, it's a right triangle. If you substitute them in and you get a false statement, you don't get the answer you're expecting, then nope, not a triangle, not a right triangle at all. All right, it's your turn to practice. I hope this helps. I believe you can do it. If you have any questions, check out the resources IXL has for you, or of course, reach out to me. Bye, everyone.